So I suggest we quickly recap the previous episode to refresh our memory. As you remember, we firmly decided that the van from the future should be an electric car. That's why Kolya welded this subframe. The electric motor will be mounted on it, which we paired with an automatic transmission and installed as follows. Then we connected all of this to the axle using a custom drive shaft. Something like that. And the mission for this episode is to get the whole setup running and make the wheels turn. Spoiler alert, the mission was accomplished.
Here's what we received: the battery and the inverter. I guess we should try fitting all of this into the car now. To do that, we'll be unpacking our new helper, which can handle up to 2 tons.
Yeah, obviously the factory layout from the Nissan Leaf doesn't fit at all into the body of a futuristic Bukhanka. Spoiler alert. We had to completely rethink the layout. But Kolya doesn't know that yet and is still playing his own game of Tetris.
As a whole, the battery doesn't really fit anywhere for us. Not in a way that looks nice and organized. So now I'm gonna try taking it apart.
Basically, we spent almost the entire day coming up with and searching for the best way to arrange all the components. At first, we decided to try breaking the blocks down into smaller ones and distributing them evenly around the perimeter. We took them apart, separated them and tried fitting them in.
For now, they're standing here on the mounts. I'll probably add 3 more here and 3 more over here, and then we'll make some kind of bracket underneath for them going around the drive shaft. The drive shaft doesn't move up much, so I don't think it'll get in the way. We'll leave some clearance there. Part of the battery will fit in here. So the batteries arrived from the guys in a near factory configuration, but to install them in our van, we'll reconfigure them. We'll weld separate power cases for them, which will be sealed in the future.
After a brief brainstorming session, we ultimately decided to abandon the idea of evenly distributing the batteries along the entire frame, since that setup would have required us to make a lot of connections, which is time-consuming, expensive and not very straightforward. In the end, it became clear that we needed to make 2 large separate blocks. That's actually what Kolya is working on right now.
We decided to place all the batteries into 2 blocks. One will be placed on the left and the other will be placed on the right. We abandoned the layout where we would spread all the batteries across the entire bottom. We settled on this option because it's easier to wire and requires fewer cables. Well, in theory, this should help us in the future. The boxes themselves are designed in such a way that it's convenient to remove them either to lower the entire battery box down with the car, or simply to detach, say, the bottom frame and pull it out with the batteries from under the car. Everything rolls in, it's all quite convenient, and it turned out pretty well. This is to avoid jumpers here, because the original wiring harness will run through this area. I use the original jumpers that go inside the battery and are connected internally with through studs, and the 2 frames are connected with these bolts. Everything turned out compact and quite simple. Everything's connected, the frames, the bolts, everything. This is what it looks like in its final form. Now we're positioning the block in the body so nothing gets in the way. There was a gap for switching, for wires, for everything. I prepared these plates with embedded nuts. They will be placed here. Reinforcement gussets will connect inside the longitudinal member, distributing the load evenly. In front, mounts will be here, mounts here, and a brace here. This is the kind of construction we ended up with. I hung the box. It's suspended from above using these plates, matching plates underneath, and here the embedded nuts are welded so that everything can be screwed and assembled from below. A cross member in the longitudinal frame ensures the load is distributed evenly. For now, it doesn't look very nice, but it will all be tidied up later. After a long break, we're getting back to work on the Bukhanka. We've laid out all the components that the guy sent us. We're figuring out the layout, where everything goes and how it fits together. Now I'm going to remove everything unnecessary from the inverter because our space is very limited, and I'll try to fit it in, try to install it and look for a spot for it as close to the motor as possible. This is the picture that's starting to take shape. I diligently tried to find a suitable position so I wouldn't have to completely redo this rather huge connector that's supposed to go right here, but there just isn't a practical way to fit it directly into our current layout. Either the batteries get in the way, or the lamps, or the pipes. Basically nothing really fits well because the connector is just so huge and powerful. And in fact, we're still gonna have to redo it. Most likely, we'll take it apart. It's designed to be disassembled. We'll extend the wires and reassemble everything using the same connector, just with wires of the length we need. So for now, everything is set up like this. At the moment, it's roughly propped up on stands and jacks temporarily. There are gaps everywhere here. All the wire connectors are free. Everything will be connected from below. just like we always do, including the water cooling. So basically the water is routed out. The problem is that everything is sticking out in different directions everywhere. Whenever you pick a certain position, one thing gets in the way of another, and I ended up spending the whole day trying to choose the lesser of two evils. So apparently we'll still have to redo this one fitting because it's pointing straight down, and we'll most likely reroute it either here or there. Then we'll check the diagram to see what it powers and where it gets its power from. Now we need to come up with mounts for all of this, but that seems to be just a technical matter. Gaps everywhere, everything seems in place, level with the floor. We considered installing this in back, but obstacles exist there. 2 drive shaft interferes, brace gets in way. So most likely everything will be set up roughly like this. It will be connected and routed accordingly. The cooling system and everything else will be connected.
Well, after that, it's really just a matter of technique. It only took 2 Kolia days to invent, fabricate and install all the mounts. Of course, without quality tools and equipment, it would have dragged on for a week. Many people have asked about our welding table and requested a review of it, but reviews as a format have never really been featured on our channel. And here's a question for you. Should we make a separate section for this, or is it better to just include small inserts in the main videos? This is actually important.
I've already hung up all these boxes. We can't really get a nice shot in there, there's just not enough space. Let me show you now. Here it's mounted at the top, and here at the bottom there's this kind of bracket. Everything is assembled at specific points, and here is this kind of bracket. Here there are embedded threaded sleeves, the actual bracket, 2 mounting points here and 1 more point over here. The challenge was to maintain access to these connectors so that everything would fit together here in terms of layout. There's another connector here, connectors here, and the water cooling system. So everything is tight and compact, but there are gaps everywhere. There's also a threaded rivet here. We laid out the wires here minimally, just the ones that arrived for us. We realized that we need to extend some and buy a few things, and while we have time we need to remove this battery block and swap the batteries around, because I assembled them for the original connection cassette where they're connected in a sort of checkerboard pattern. But we need to assemble it so that we can align everything with just one bus bar. Yes, by this point we decided to use a different switching method. In our opinion, it's much simpler and more reliable, especially considering our current layout. Previously we had them assembled like this: red, 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 in a triangle, red, red, red. And now they need to be assembled like this, exactly along the strips, so that we can just make a not copper bus bar with holes and connect everything together. It actually seems like it will be even a little bit easier this way. So from this block and that block, we'll be able to combine them and make these kinds of packs. The missing batteries that we ordered have arrived. Now the task is to take out from these packs the ones that Alexi marked with a cross. There are quite a lot of them here. Once again, we need to unpack them, take out the marked ones, and replace them with the ones that just arrived. Then we need to assemble everything again, balance it, and then reassemble the batteries in the same checkerboard pattern as before, so we can connect them and install them in the car. It's like we're playing chess or a sliding puzzle here, but that's just how it has to be. Let me explain a bit. From the start, we knew that some cells were dead and would have to be replaced. We tested all the batteries, identified the faulty ones, and ordered identical cells to replace them. So right now we're busy with the replacement and reassembly. Once again, I reassembled them, threw out all the defective and worn out ones. So now we have a whole box of them. I don't know what will happen to them next, or where we'll dispose of them yet. And I assembled this one. I had to flip one over because it turns out there are left and right batteries. For now, just to balance things out, I put it in first temporarily. Later we'll decide what to do with it and how to handle it properly. 2 of these towers are seriously heavy, I have to say. The next step is to connect all of this together. That's why we're taking apart the factory wiring and starting on the custom modification. The wires, terminals, and this special tool for crimping terminals have arrived, so everything will be neat and precise. This is a special metallized conduit. We'll use the metal in it as a shield. The conduit is thicker and the wire is really heavy duty. This is kg 25, this is kg 50, and this is kg25. All right, now we're going to cut, measure, check, crimp, cut again, and load everything into the car. And then it's hours and hours of cutting, wiring, crimping, and other electrical work. We double check and test everything, since the voltage here is no joke and can reach up to 400 volts. Alexei and I connected the wires, bundled them up here. All the wires are here, and this connector is almost ready to, just needs a few finishing touches at the end. Now we're putting everything back in place. Yes, on camera it all looks simple and fast, but in reality that's not the case. Since this is our first time, we often run into nuances and questions, stopping work to discuss things. This is our previous steering system, but we ultimately decided to abandon it due to the complexity of setting it up with a stepper motor from a CNC, separate controls for it, all sorts of things, and adapters. Well, it was clear from the start that the system was a bit too complicated, but we couldn't manage to make it work ourselves. We only came up with a simpler system, thanks to the guys. Now we'll have this kind of steering system. This is the Nissan Leaf steering rack. From the same place we got our motor, and now the rack itself will be turning. Not a CNC motor like we had before, but the actual steering rack itself. So for the steering, all we need now is this thing and the joystick. My immediate task now is to carefully connect the technical vehicle. Most likely, I'll have to systematically remove all this existing extra stuff and then precisely replace the current mount for that particular rack with a more suitable mount specifically designed for this new rack. It works much better than our previous version, so we've decided to throw all that out again and install this one. So to change the rack, we need to swap out this platform for the stepper motor, the platform for the rack that's a bit further back, and this mount will have to cut it all off, cut it right here. Basically, we remove all of this completely and weld everything for the new rack from the Leaf. We have a piece of the drive shaft from the Leaf, in fact. We have the whole thing, so we'll use a section of it for this. And we also have the matching part for it. Now I'll see how to connect all of this in the best way so that it looks decent and works perfectly. But it's a shame that we'll have to cut all of this off, of course. I put some effort into this, even did some welding. As you might have guessed, the mount that we spent half of the last episode making, we're removing and throwing away in this episode. What can you do? That's the job. Like I said, we're not filming a masterclass. We're telling our own story, making mistakes, redoing things, and honestly, sharing it all with you. I took apart the electric power steering, removed this thing here, the cover that goes on the steering column, onto the steering wheel. Now we have the shaft. Here's the safety feature, the splines that allow the steering wheel to shift in case of an accident. And I truly think that none of this information will be particularly useful to us. We'll cut it right here. I'll just cut it right here. I'll seal this hole here, and it'll just be a dust cover basically, so dirt doesn't get in. We'll have a rotating part only on one side, and from here it will go out to the rack. We absolutely don't need this part. There won't be a physical steering wheel in the car, so now I'm going to carefully cut here, slowly, little by little, so nothing overheats. I'll seal up everything in there now. There's kind of an oil seal, but just in case I'll probably seal it anyway.
As you've realized, we've completely abandoned the physical steering wheel. In the end, there will be some kind of joystick in the cabin, and there will also be an option to control the car remotely via Bluetooth using a PlayStation joystick.
I've installed the electric power steering in advance. Now we wait. Right away, I messaged the machinist to make an insert for us here. The original splines will remain here, just as they were. And here we'll reduce the diameter. There will also be a connection. It sits about like this. The universal joints are straight. The angle's absolutely fine. All that's left is to figure out how to secure it here. And here I've finished the cover.
As you've probably realized, we removed the old stepper motor mount, as well as the stepper motor itself. Now we need to come up with a reliable mount for the Nissan Leaf electric power steering. Just about an hour and a half of work, and this is the result we have.
This is the kind of mount we ended up with. Here I used pieces of the original mounting hardware. It all fit perfectly and blended in here. Here is the reinforcement, here's another mount, and here is the rear support bolt. This is the main shaft. The machinist will return the drive shaft to us very soon, and we'll connect it right here. We'll hook everything up and then start steering. Now I'll explain precisely how we're controlling the bukhanka. We have a standard PlayStation 4 joystick It connects seamlessly via Bluetooth technology to an ESP32 board. This board diligently receives precise analog values from the joystick and then efficiently sends them to the electric power steering system. And as a direct result, our vehicle's wheels turn accordingly. But for them to turn with a certain amount of force, that depends on the speed. Since we don't yet have a dedicated speed sensor, we are currently sending a signal from an Arduino through an MCP215 module along the line, which indicates a zero speed, so our wheels can turn very quickly and easily. We are now about to do the very first rough test run of this system. Lyoka didn't even unwind anything. We made and extended the drive shaft, everything's ready. It's just the first start, we didn't even clean up. Curiosity prevails. Go ahead.
Alright, let's enable the electric power steering. Click.
Something is clicking now.
Whoa!
Whoa, look at that. Something's in the way here, or maybe not.
So, is there any movement?
Go for it.
It's inverted right now.
Very fast indeed. But you can certainly make it much slower, right? Well, that's cool. There you go. But it's adjustable, as far as I understand. So the system has proven that it's fully operational, controlled precisely from the remote. It's like a joystick. You can see both the joystick and the wheel. And for now you still have the inversion. Left and right are swapped. That doesn't matter at all. This is what it looks like in its finished form. Here I kept the factory splines. Here it's been machined and it's fixed in place. Here maybe later there will just be a cotter pin. Here is the original drive shaft. The motor itself, the motor mount of everything is pretty decent. While I have time, I'll be studying it. What is this anyway? How is it even gonna work? The main brake cylinder from a Leaf, which should also be operated by the joystick. Braking, figuring out the intricate wiring, figuring out precisely how to connect all of this complex system. Right now, I'd probably remove this thing to make it more compact. I'll check now to see if that's even possible. Figure out which is the front line and which is the rear. For now, we'll plug the rear one. We'll only have one left since we don't even have drums in the back yet. And there will be calipers in the front.
Here we decided to take the path of least resistance and use brakes from the same Nissan Leaf, since all these components were originally part of the same system, and integrating them together is much easier. Besides, this is a component from an electric car, and the operating principle here is different from that of a car with an internal combustion engine. And as a result, implementing both brake and throttle control via joystick will be much easier. But more on that a bit later.
For now, this is how the master brake cylinder will be positioned. Here is the spot for the connector to come out. Here will most likely be the place for the remote reservoir. Most likely, excess here will be cut off in the future. From here there will be a mount upward.
Well, now there's just a little left to do. We still need to come up with just one more mount. Fortunately, by this point Kolya had really gotten the hang of it, so it took less than half a day, and by evening we already had this amazing thing.
This is precisely what the finished mount ultimately looks like. Everything screws in, everything fits in place. Here we'll have the wiring harness coming out, and here the tubes will go to the front, to the back. This will most likely be removed in the future. Now it all comes down to the tubes and hoses. We ordered hoses and caliper repair kits. We have these brake calipers readily available on hand. They are sourced from a MIDI vehicle. Their current condition, of course, is pretty dire indeed. Everything is seized up, it's all in really bad shape. The guide pins are bad, there are no pads. The cylinder is apparently stuck, and the hoses are dead. A complete restoration, a full rebuild is truly and indeed needed because it's all just really bad.
Now many of you are probably wondering, why are we using calipers from a Suzuki MIDI and not from a Nissan Leaf? The thing is, originally a Suzuki MIDI was bought as a donor vehicle. Of course there's not much left of it, but the entire front axle is actually from it. And that means the calipers will bolt right on. Now all that's left is to turn this old junk into new, nice looking calipers.
Today I'm working in my own personal garage. I have this little amateur sandblasting cabinet, and we're getting the brake calipers ready. First of all, we absolutely need to mask everything off, cover all the crucial holes, especially where the threads are located. Right now, they're in this current condition, just about as rusty as it possibly gets. So we decided not to clean them or anything, just to take them to the garage, sandblast them, and paint them. This is what the mask part looks like. That way the sand won't damage the threads inside. The cylinders themselves are completely covered with the old worn out cylinders. We have a new set in the repair kit. These are hose cuttings, and here's the bleeder. This is what they look like after sandblasting. All nice and really clean. Of course there are some deep pits on them, but I don't think that'll affect anything. That's it. Now they need to be blown off, degreased again, and painted right away. So here's our painted caliper, the seals from the repair kit, and a new piston from the kit. And we'll assemble everything using special grease specifically for brake system assembly. That's it. We put in the seal, the dust boot, the cylinder, assemble it, and run through the thread just in case any dirt remains under the seals. That's all. This is precisely what the calipers look like after being completely rebuilt. I've meticulously cleaned out all of the painted threads. Here is the grease for the guide pins. There is the grease for assembling the calipers. All that's left is to buy new bleeder screws because the kit, the repair kit, didn't include any. Other than that, everything is painted, moves, works, looks great, and operates smoothly. While Lesha is starting the engine, I'm working on the brake system. I installed the master brake cylinder and mounted a separate reservoir for the brake fluid. Right now I'm working on routing the hoses so that from the hoses I can run the lines, T-fittings, and distribute everything. I had to cut out these holders for the hoses and weld them in place right on the spot, making sure nothing gets caught anywhere when the steering moves. Since we have increased steering angle, and well, this is what the finished system looks like. Here's the caliper. The hose is attached here and here. Next, copper tube will go in. When the steering operates, nothing gets caught, nothing kinks, everything is safe, nothing rubs or pinches, everything is great. Now I'm gonna repeat the same process on the other side and start laying out all the main lines. As for the brakes, the Nissan Leaf brake cylinder again works on a principle similar to a vacuum booster, but not exactly. Instead of a vacuum, it has a motor inside and it will help us brake our van. Alexei will also explain how it works and how we'll connect it to the gamepad. I installed it, set up a reservoir for it, connected them, ran the brake lines and hoses, and welded all the mounts. We haven't filled or charged it yet because Alexei will be removing it to connect everything. Today we're dealing with the power outage. There was some kind of accident at the substation, so we're working in daylight. I guess I'll keep assembling the batteries.
By this point, we've finally settled on a method for connecting the batteries. So what does it look like?
This is what our assembled batteries look like after being put together yet again. Right now, once again, I'm carefully hooking it onto the hoist and gently rolling it into the car. The battery is securely hanging, the battery is indeed hanging, and everything is properly connected. The motor is connected to the inverter, specifically the power inverter. The inverter is then connected to the PDM, the power distribution module. All that's left to do now is to connect the power cables, one right here, one on the other side, sort out this tangled spaghetti, and maybe try spinning the motor just a little bit, hopefully. Just a little bit. Hopefully we won't burn it out. We'll lift the rear axle just in case it suddenly decides to go somewhere. Because so far, no one really knows how the automatic transmission will behave here. Now we're going to try something, take some action.
Yes, in the comments under the previous episode, many people asked, why are we using an automatic transmission, and in general, why do we need a transmission in this setup? We'll explain this in detail in the next episode, when we'll actually be testing the car in motion. Right now, our task is to spin the wheels, so to speak, to check all the connections. We've suspended the rear axle in the air. We double-checked everything that could be checked, and now we're getting ready for the first start.
We'll also have throttle and brake implemented, but this board is already a bit insufficient for that. Additional DAC, modulus digital to analog converters will be installed, and the system will work the same way. The analog triggers send the signal to the ESP32, which then sends it to the DAC. The DAC goes to the PDM, for example, for the throttle, And that's how we'll implement both throttle and brake. We've connected all the electronic modules. They connect to the PDM units through contactors. The positive line is shunted with a resistor, while the negative is connected directly. So when powered on, the negative contactor closes immediately, while the positive one doesn't close right away. Instead, the capacitors in the PDM are gradually charged through the resistor, and once the nominal voltage is reached, the PDM detects this and activates the second contactor. At the moment, all our controls are routed to simple switches. This is just for testing purposes. Next, as we mentioned, the control will be from a gamepad. This will be the accelerator pedal. For now, the battery charging is set up in this simple way, just plugged into a regular 220 volt outlet. So our battery packs do not have a dedicated BMS board or system. Charging is instead carefully monitored by the PDM. We will have an actuator installed on the automatic transmission, which will switch the position between parking, drive, neutral, and reverse. Control will also be carried out using a gamepad.
While Lesha plays with the joystick, Kolya checks all the units. And finally, the first press.
Here we go, indeed. Oops. Spin it fast. Lyoka.
It got exposed right away.
Is the wire rubbing against anything over there?
No, the wire goes forward right here. Regarding the latest work on the Bukhanka, we changed the steering, got rid of our old electric power steering from a Renault Clio and the stepper motor from the CNC. Well, because that setup was just too complicated. We installed a single electric power steering unit from a Nissan Leaf, and Alexei, with the help of the guys, taught it to work with our steering system. It turned out precise, compact, reliable, with no unnecessary components or extra connections.
By the time this episode is released, we're already actively testing the Bukhanka in the field. Thanks for watching, and may you have a good X.